Hi, I'm Cassie, and I'm going to walk you through question 37 of the AAMC's official physics question pack. This question is all about understanding how to find the relevant information in the passage, in this case, an equation, and plug into it. So the question asks about what frequency of oscillations happen at a certain density of plasma. So we want to go back in the passage and we want to find where it talks about the density of the plasma. And you'll see it does that in the bit of text right before it presents you an equation. And now that equation looks pretty scary. I don't want to have to plug into that. If you notice, they actually give you a shortcut equation. They say that this really complicated equation is about equal to just 9 times n to the 1/2. And what is our n here? We're told that the frequency of the oscillations occur for a given number of electron density, n, which is given in electrons per cubic meter. And that's exactly what we're given in our question stem here. So all we have to do here is we just need to plug in that number we're given in the question stem as the n in this equation. So let's go ahead and do that. If we have 9 times 10 to the 18th, and then all of that per cubic meter, all raised to the 1/2 power. And remember those fractional exponents, that's just like the same thing as saying the square root of all of that quantity in the parentheses. And when we have those fractional exponents, we can just multiply the fractional exponent by any exponents inside the parentheses that it applies to. So in this case, we're going to keep that 9 out front, but that 10 to the 18th, we have to take 10 to the 18th times 1/2. And then of course we have to do the same thing for our units, meters to the -3 times 1/2. So if we simplify that, we're going to get 9 times 10 to the, what's 18 times 1/2 is 9th, and then meters to the -3/2. Now notice that that should be answer choice C for me at least. So the answer is going to be 9 times 10 to the 9th hertz. Now some of my more detail-oriented students get confused because they say, wait, meters to the -3/2, how is that equal to hertz? Well, that's where this gets a little more complicated. So we said that this was our simplified equation, right? It started out as this, and then we simplified it to make it easier. But when we did that, some of the units get implied that they were sort of absorbed into that 9. So this 9 here, it might seem like a constant, but it actually includes a bunch of units. So if we were to take into account those units that got condensed into those 9s, and we were to then go ahead and multiply that by meters to the -3/2 here, we'd end up with hertz. Now, something that's really good practice to do here is to look at all the units in this original equation and how they cancel out to get to hertz. So let's do that together here. This is really honestly worth the time, again, if you're not comfortable with converting between units, because while you didn't have to worry about it so much in this question, there will be a lot of MCAT questions that force you to convert between different units. So I'm not going to worry about the numbers that go for any of these quantities. I'm just going to sub in the units and see how they cancel out. So for example, what's K? The passage tells us that K is Coulomb's law constant, 9 times 10 to the 9th Newton meters squared per Coulomb squared. So let's go ahead and I'm going to just put equal. The red part is just going to be all units. Okay, so that K is going to just become my units, Newton meters squared per Coulomb squared. And then we're going to multiply that by our N, which we said was electrons per cubic meters, which we can just simplify as 1 over cubic meters. And then we're going to multiply by our E, and E is the elementary charge, which is going to be given in coulombs. And don't forget to square that column. So we've got Coulomb squared. I'm just going to write over 1 here. So you got to make sure everything lines up in the numerator and the denominator perfectly. Okay. And then this whole quantity is raised to the 1/2. What do we have in the denominator here? Well, we have pi. Pi is just a constant, so we can ignore that for the purposes of the units. And then we have m. And we're told that m is the electron mass, which is going to be measured in kilograms. We always measure mass in kilograms, right? So we got all of this over kilograms. Okay, now let's simplify and combine things. Well, what's the first thing you notice? Our columns squared here are going to cancel out, so that's nice. We have meters squared in the numerator here, but meters to the 3rd in the denominator. So all of our meters in our numerator here are going to go away, but we're going to keep only 1 meter in the denominator. Okay, so let's start writing this out so we don't lose track of what we just said. So we said we still have our newtons are here. Our columns went away. And then under that we're going to have 1 meters left, right? And then all of that divided by kilograms raised to the 1/2 power. Okay, to simplify a little more, remember dividing by anything is like multiplying by its inverse. So we're going to leave our Newton meters as they were, but now we're going to multiply by 1 over kilograms. So essentially our kilograms are just going to go into our denominator here with our meters. And then of course this whole thing is still raised to the 1/2, or you're taking the square root of it, right? Now, I don't like this. I've got newtons, meters, kilograms. I don't know where to go from here. Well, this is where knowing your unit conversions is super important. You need to know for the MCAT that 1 Newton is equal to 1 kilogram meter divided by second squared. Okay, so 1 Newton we said was equal to 1 kilogram meter divided by second square. And how could I figure that out? Newtons is a measure of force. Our classic equation for force you need to know for the MCAT is that force equals mass times acceleration. We know that mass is measured in what? Kilograms. Acceleration is measured in meters per second squared. So here we have force, which is measured in newtons, is equal to kilograms times meters per second squared. So super easy to remember, again, if you think about these things. Okay, so we said that's our newtons, and then we're going to divide by meters per kilograms, and we're going to take the square root of this whole thing. Let's go ahead and let's simplify some more. We said that dividing by anything is like multiplying by its reciprocal. So now we're going to get kilograms times meters over seconds squared, and we're going to pull up this part. So we're going to get times 1 over meters per kilogram. Okay, now let's see what can cancel out. We can cancel out our meters, we can cancel out our kilograms, and we get the square root of 1 over second squared. In other words, we get second to the negative second and the square root of it. Remember, that's like saying seconds to the negative second raised to the 1/2. And if we multiply our exponents together here, we're going to get seconds to the -1, seconds inverse. And remember, the definition of hertz is 1 over seconds. So that's how we get to our hertz units here. So again, super good to do extra work like this on problems when you're reviewing them, just to make sure you're fully understanding what's going on, like these unit conversions that you're going to need for other problems on the MCAT. So I hope this helps. If this helps, give this video a like, and please follow my channel for more content like this.